Fundamental problem F12-3 says a particle travels along a straight line with a velocity of v equals 4t minus 3t squared meters per second, where t is in seconds. Then, we're asked to determine the position of the particle when t is equal to 4 seconds. We also know that s equals 0 when t equals 0. Alright, so first of all, I'll go ahead and draw this particle here in red. And here an arrow indicating its velocity. And then I'll go ahead and add a scale underneath that representing the position. So here we have position 0, which is the initial position. And then arbitrarily over to the right is going to be the second position of the particle, which I'll label as S. And this of course is position in meters. And now we can go ahead and draw the particle at state 2, which in this case is S. And for the initial state, we can go ahead and label this S1 and T1. And then for the second, S2 and T2, where T is of course time in seconds. And from the statement, T2 is equal to 4 seconds. And we assume S1 and T1 as 0. And so from the statement, in this case, we want to find S2 since we are asked to find the position of the particle at t equal to 4 seconds. And so of course we are told in the statement that the particle travels in a straight line. So essentially we're focusing on rectilinear kinematics. And well, from this we fundamentally know that velocity v is essentially equal to the derivative of position s with respect to time. And remember that basically ds is the change in position s2 minus s1. And similarly dt is the change in time t2 minus t1. And now if we isolate ds, we get ds equals v dt, just like so. And now since we want to find position s, we essentially need to undo this derivative. So we need to integrate this function. And once again, we know that s equals 0 when t is equal to 0. So defining our integration, we can integrate ds from 0 to some value s. And on the right side, integrate v dt from 0 to some value t. So hence, after integrating, we get s is equal to the integral from 0 to t of substituting in the value of v as 4t minus 3t squared times dt. So simplifying this, we have s equals 4t squared divided by 2 minus 3t cubed over 3, which is defined from the boundary 0 to t, which in this case t equals 4 seconds. So here think of it as t1 equals 0 and t2 equals 4. So therefore, after evaluating this, we'll have s. Well, first of all, let me simplify this fraction here. So 2 cancels out, 4 goes to 2. And on the right, the 3's cancel out. So essentially, we are left with s equals brackets 2t squared minus t cubed from 0 to 4 seconds. And now substituting in the values of t, we have s equals 2 times 4 squared minus 4 cubed. And then on the right side, minus 2 times 0 squared minus 0 cubed, which of course just goes to 0. So after simply evaluating the left side, we get negative 32. So therefore, s is simply equal to negative 32 meters. And since the negative here just indicates that the particle is to the left of the starting position, if we assume to the right as our positive x direction, we can also just indicate this as 32 meters with an arrow pointing to the left.